Hello.
Is my voice clear? Students, today is the first session of our live session, and today's session will be handled by Professor himself, Abhijit sir. Okay, so after the session, we have Q&A sessions. You can put your questions at that time. Questions related to operational things, kindly mail to our support team. Okay, sir, kindly start.
Okay. So since this is the first live session, I first wanted to give you all of you a chance to ask questions, and then based on that, I will go ahead and talk about some of the things that I will be, focusing on. So let's flip the overall interaction, and I would like to know from you if there are any questions. Anyone has any queries? I'll give you a couple of minutes to think. There is I'm unable to look at this chat. Someone from NPTEL can help me. When I click on it, it doesn't seem to open.
Okay, sir. So there is this chat icon. Maybe can you check in the background whether it's opening?
Yeah, maybe I have to do speaker view, is it? Yeah, thermodynamics and chemical engineering. There are some questions. When it pops up, I can see it, but somehow I'm not able to see the chat window itself.
Okay, at the bottom.
Yeah, I can see that thing. Okay, now it has come. Yeah, okay. Okay,
Okay, sir.
yeah. So the students cannot speak, is it? They can only enter comments in the chat. Is that correct?
Sir, because the students are
Yeah, they're muted, right? Okay,
can hear
okay.
you.
Yeah. Sure.
Anirudh Sri Ramala, can you unmute and say something?
Yes, ma'am, my phone is speaking.
Okay. So in case needed, you can speak also, and of course you can also give your comments through the chat box. Now I am able to see the chat box, so we can look at some of the questions that are there on the chat box. So let me just open so that I can write and share my screen so that you can. Okay, that gives me something to write on. I'll just add a couple of pages so that we can scroll through. And let me just 1 second. Yeah. So we can start. I'll take question one by one. Let's look at. Let me just start from the first question so that we can start. Okay. Yeah, Joshua, your technical errors anyway, NPTEL team will take care. We will. Yeah, what is the role of as triethanolamine as see, since there is an amine group there, So therefore, it contributes towards maintenance of pH. So because what happens is you have acid, and since the assembly of all the acid groups and the tail, see, remember while discussing, we had talked about the surfactant being, I'll just share my whole screen so that I can write. I hope you are able to see the screen. And
Yes, sir.
so we had talked about surfactant being a molecule like this, where there is a hydrophilic head. Quite often this is charged also, and then there is a hydrophobic tail. And this has groups like CH2, CH2. That's why it's called hydrophobic tail. This is, see, wax also, it's CH2, CH2, and wax is also very hydrophobic. On the other hand, this can have sulfate, this can have acid. So therefore, these are all the groups which are hydrophilic. While these are hydrophobic. So there is no specific different way reaction has to be carried out to get the surfactant molecules. In fact, in plants also we have many surfactant molecules which are called biosurfactants. So they are also produced within the plant world. So many of these molecules, if they have this kind of a nature where one side of the molecule is very different compared to the other side, then it becomes a surface active agent. And so there is no special way of making the surface active agents. It's like just like any other chemical also. And so the question that was asked, let me just go back to the screen and look at the chat. So stearic acid is an example of surfactant itself. So they are one and the same. Given that stearic acid has this acidic group and then it has a long hydrocarbon groups also. So therefore it functions like a surface active agent. And so because how acid groups will interact with each other depends on the pH, therefore the triethanolamine is added as a pH modifier.
Sir, so is
And
there any
yeah.
particular reason for using this compound, or we can use any other
No, so
compound?
there are various different agents also used. That depends on, we have to remember that if we are using this as shampoo, then it's, effect on our skin, our body also has to be taken into account. So technically, you could use many other things, but given that some of them may harm our skin, so those, pH modifiers which are safe to use are the only ones that can be used.
Okay, sir. Thank you.
In chemical, so maybe I'll start. So there's a very general question on role of thermodynamics in chemical engineering. And there is a lecture also which is related to later on in the second week probably that you will come across, which is related to, we have taken example of sugar and jaggery. So, for example, jaggery is a completely Indian sort of Indian emphasis product, and it's made in very small scale places. So that's why when you go and buy jaggery, sometimes its color is different, sometimes its size is different. The blocks made are completely different shapes because it's all sort of done in various small scale industries. While sugar, on the other hand, is done in very large scale. It's more refined. You, in fact, remove a lot of things, and jaggery has a lot of minerals. So that's another reason also why, sometimes the taste given by jaggery is considered to be, some people prefer it, or from the point of view of other than, sugar, other things which are present in terms of minerals, can be beneficial with jaggery consumption. So with these two examples, which are, everyday, there are various things in which we have to change phase. For example, we start with sugarcane juice and then we have to crystallize sugar or jaggery. So there is a phase change. So thermodynamics is involved in terms of trying to figure out under what condition we should do the crystallization so that we get appropriate amount of sugar or jaggery. Similarly, while doing this, to do the crystallization, it may be better to concentrate the sugarcane juice by evaporating the water. So therefore, there is another phase change involved where we now are trying to make liquid water go to steam or water vapor. So therefore, thermodynamics is very centrally involved in chemical engineering because we are interested in producing some product, and we are interested in a pure product or some form of the product. So we always have to carry out some separations. So therefore, thermodynamics and separations are very key sets of processes in chemical engineering. You would also see that thermodynamics is equally involved in mechanical engineering or other branches of engineering also. There's one other place where thermodynamics is again very important in chemical engineering is in the case of reaction. Because let's say we are talking about various reactions, let's say to make sulfuric acid or to make we will look at one particular lecture, we will look at chemical vapor deposition as a process where we can deposit silicon. This is useful for semiconductor processing. So there is a compound called silane which reacts. And so in this kind of a chemical reaction, again, we would like to ensure that we would want to understand what is the extent of equilibrium, what is the rate of reaction, and can we go as close to the equilibrium as possible so that the extent of reaction is more. So in terms of chemical engineering, we are interested in thermodynamics, both for phase change and also in terms of reactions. Many times as a first learning, we also learn about a single component itself. For example, water can exist in liquid, vapor, and solid. So just to understand the thermodynamics of a single substance like water is also very useful, because one other question that was asked in today's session is what is the fluid used in jacket, right, which is cooling, and that can be water quite often. Or if it's a heating, then it could be steam. So water is a utility, fluid, which is there in chemical processes and chemical plants. So just to understand how water goes from steam to water liquid and liquid water to vapor water or steam is something which is of great interest. So therefore, in a summary, for as far as thermodynamics is concerned, we need to know single component like water and all its phases. Then we need to know mixtures and how they are separating from each other or how they are combining with each other. And then finally, when we talk of reactions, there also we need to know thermodynamics. So hopefully that gives you an idea of the central role of thermodynamics in chemical engineering. And so other question is, so stearic acid itself is a surfactant, but not all acids will be surfactants, because there are only few acids which have, so there is palmitic acid also, many other acids which have long these CH2 groups, which can function as a hydrophobic tail. So an acid, of course, because it has protonation, right? It has an H plus which it can generate. So therefore, a molecule which can do protonation as well as it has a long tail can act as a surfactant. But there are so many other acids which will not be surfactants. So as far as process control goes, see, for an EV or so in all of these, whether it's a product, electric vehicle as a product, or even let's say petrol driven car as a product, there are various measurements being made. And based on those measurements, control is being done. And so, for example, even when we press the accelerator, how much the speed should be is based on a feedback. There is always a feedback in terms of measurement of some quantity. So speed is being measured, and then the fuel line is opened, or the IC stroke engine is increased. But in case of electric vehicle, a higher amount of current has to be passed. So to do all of this decision making, we have what are called loops. So these are called control loops, where we measure something, we have to control something, and we have to control something by manipulating something else. So in the language of process control, we have manipulated variables, controlled variables. And so to do this manipulation and control, we also need to measure so that we know what is the status of the process. So in electric vehicle, you will have measurements in terms of, what's the status of the battery, what is the level of current that's going on, what is the requirement of current in 2-3 different aspects of the car operation, what may be the temperature, and so on. So various states within the electric vehicles are being monitored during this operation. And there will be hundreds of loops which will be there to try making the decision, saying that this temperature has to be lowered, current has to be increased, and so on. Now, one other question is related to plastic pyrolysis. I'm not sure where this comes from, but let me just read it. In chemical plants like plastic pyrolysis, the feeding system of reactors should be 100% leak-proof. How can this feeding system is made and controlled, and hydrocarbon gas cannot come out of the reactor while feeding is continuous? No, so I'm not quite clear what is the sort of any operation that we have, any reactor, it should be leak-proof. It is not just related to plastic pyrolysis alone. Because leak implies, unwanted liquids and vapors getting out of the system, which cannot be allowed in any system. So in fact, even in kitchen, when we are doing cooking, we will not allow.
Sir, so what technology is used to make this feeding system work? How can this be modified so that feeding is continuous but no gas can enter and no gas can come out?
Well, a couple of things that are done. You have what are called one-way valves, right? So that it's in fact in our body also there are one-way valves to many times to regulate so that you can isolate effect of one particular section of the plant from the other. You can work with one-way valves, which allow basically the things to go from one side. The other thing you can also do is pressurize, work with pressure so that, things will always move from higher pressure to lower pressure. So if pressures are manipulated, that's another way. Other thing you can do is the interior of the reactor is designed in a way so that the chambers are not connected directly, immediately. So internally there are like compartments, so that you can feed into one compartment and then internally it moves into the second compartment where reaction pyrolysis can happen and gases can evolve. So you try to separate. So these are the strategies, right? So let me summarize again. One is to use one-way valves kind of setups. Second is to use pressure itself, a way of manipulating so that you don't have a backflow of anything. Backflow is what you're saying, which is very, important to avoid. And then the third strategy is to compartmentalize the overall reactor in such a way that direct connection between the feed stream and the vapor stream is not there.
Sir,
So
so in this case, in one-way valve, airlock valve will help?
Yeah, things like that. See, also, for example, if you just think of a combustion chamber, what you're doing is, let's say the plastic is fed in, and then what you do is from the bottom, you allow, the flow of, let's say, nitrogen, the inert gas, because it's, lack of oxygen should be there. So you want to maintain a oxygen-free environment. And so this air that you are feeding and forcing will force the whatever gases are evolving to go to the top. And since gases are lighter anyway, they will naturally go to the top, while plastics and pyrolysis will be towards the bottom. And now what you do is from the bottom, you feed in the nitrogen with extra pressure so that it is forced to go to the top and come out. So these are the way, and again, you can have a compartment where only from the central part is where nitrogen is being fed, while the plastic enters in slowly and slides in from the outer part. So things like that can be done. So this is, yeah.
Sir, I had one question on these halogenation reactions.
Uh-huh.
Sir, like when we are doing halogenation reactions, like in chemistry theory, we have studied that there will be three steps, like chain of initiation, propagation, termination. Now, if you see for like longer chain compounds, even alkanes will again be formed. Like for example, if you do methane, we'll get ethane also. So, like, what conditions will they do these halogenation reactions, sir, to get only like chlorinated or halogenated products?
There are two things you are talking about. See, initiation, propagation, and termination is for a, it's a series of steps involved for any chemical. It need not be halogenated. For example, ethylene, right? Ethylene is CH2CH2. Now, if I react ethylene with ethylene through, let's say, somehow I am able to form a free radical which attaches to ethylene, it again becomes free radical, another ethylene can attach. So this is basically initiation and then propagation. So there is no halogenation involved, but still initiation, propagation, and termination can happen. When two radicals come and react, they terminate.
No, yes,
So
sir. Like,
polyethylene, right? Polyethylene and polythene are exactly formed using the same three steps. So that has nothing to do with halogenation.
that no, what I'm saying is like, in
Ah.
that we learned that like in the last step, chain termination, like from methane, even ethane will be formed. So like, what do they do to maximize only a chlorinated or halogenated product and not have any ethane formed? Like, is there like what industrial methods do they use?
So see, generally, so lot of reactions which are present in the chemical processes, there is always this danger of having a byproduct form, but our goal is always to form, the product of interest. So again, I'll talk in terms of general strategies. When we go ahead in the course and we discuss few specific examples, then you will come to know of these. So one of the things that can be done is you use one of the reactants in excess, so that you drive, see, that's where again thermodynamics becomes important, because the equilibrium of the reaction can be
I need
shifted
to see
based on the
bonding effects also.
amount of reactants.
Hmm.
So therefore you can use some reactants in excess. The other strategy to follow is to use a catalyst, which will allow, one reaction to become faster, and the other reaction then is relatively slower. So
Then we
that's
can
also
even
another
use
strategy.
poisonous catalyst, no sir, like poison to inhibit one reaction. Poisonous catalyst.
Uh, Yeah, so see, for example, sometimes let's say you do not want, let's say, free radical. So, for example, how we make something UV resistant, right? A plastic which is there or any product, we will add a inhibiting agent. So, similarly, in a reactor also, we can add inhibiting agent. That's also a strategy possible.
So in industries, there might be like economic constraints which may not allow us to use like the most effective fuels. Like, what is the most common fuel which can be really effective? Is it very sustainable?
So there are two things you are asking. One is effective. What is your definition of effective? And then you also mentioned sustainable. But first, if you can define, what do you mean by effective?
So it produces most amount of energy in the form we require.
No, so again, and you also mentioned economic, right? So
Yes,
it's
sir. Like
so
it
what
will not allow
happens?
us to use the most effective fuel. Like, what is the most common one?
So no, so actually, so what happens is when we do petroleum refining, right? So we get petrol, diesel, and aviation fuel, which are sort of very high value, and a lot of petroleum refining is geared towards maximizing these. But the heavier fraction, which are called fuel oil and the furnace oil and so on, are also present. So they usually get sold as fuels to various industries. So that's one source. Second source could always be electricity. So especially now in chemical engineering going ahead, there is a big emphasis to say, can we do a lot of our processes using electricity? as opposed to, doing some actual fuel burning. And this is again from the point of view of emissions and so on, sustainable word that you mentioned. So therefore, there is that process also going on. But many times people also use, fuel which is available, which is, let's say, more inexpensive. For example, if, let's say, agricultural biomass is a waste and it is being consolidated in the form of briquettes or bagasse, the sugarcane juice, in fact, when it's made, whatever is the leftover from sugarcane is again a very important fuel source. Sugar plants themselves use it, but they also sell it to other chemical industries as a form of fuel. So industry, therefore, will use whatever comes around. So they generally, of course, will try to, have diversification in terms of what fuels they use. And you're right in the sense that it has to be economical, it has to be available, because, you shouldn't have to, reduce your output just because the fuel is not available. And thirdly, it also has to be, from these days, from an emissions point of view, you have to worry about how much carbon emissions is your plant generating. So all these three factors go into deciding what should be the mix of fuel that you use.
Thank you, sir.
There is a question which says that how is surfactant aligned in laminar form? So I think that's because I drew the diagram. So actually surfactant, I can again share my screen and talk about this little bit. Since we discussed stearic acid, and it was so that in stearic acid case, we had basically assembly, which was like this. So basically, depends on the concentration of the surfactant as to what type of assembly that will happen. And this is what I think is being referred to as a laminar form. But it can also be a form like this, which is called a spherical micelle. And so there are various different shapes. Since anyway, I'm sharing the screen, maybe what I'll do for your benefit is just quickly to sort of talk about, if we do a search, you will see, if you search in terms of micelles, you will see all different shapes. So this is the spherical micelle. We see this is a worm-like, it's called a worm-like micelle. This is the one which we talked about. Stearic acid exists in this form, and individual surfactant is like this. So therefore, all these assemblies are possible because, the tails like to be together, and sometimes even the head likes to be together. So this is called a reverse micelle. So all these assemblies are possible, and it all depends on what is the salt content, what is the pH, what is the length of the tail, what is the strength of interaction between these ionic groups on the surfactant head. So that's why there is a very rich variety of behavior possible with these surfactants. So depending on the concentration you can get, and so stearic acid concentration is reasonably high, so therefore you get these laminar or sheet-like structures. So we'll go back and look at the questions. One of the question is that, let me just, actually there are a whole lot of questions, so I maybe have to move a little bit faster here. Okay, what are some examples of cooling agent used in jacketed stir tanks? So as I mentioned, water is quite often, because water is a very safe fluid. It's also available as utility, liquid in the plant. So quite often cooling agent is water. Sometimes we can have a chiller plant to then cool water so that always cold water is available. And then in the chiller plant, we will use, a refrigerant, just like in our fridge at homes. We have a refrigerant which is going through a compression and expansion cycle. So in plant, what we will do is we'll use water as a cooling fluid as far as tank is reactors and other places are concerned. But to cool the water, we may use a chiller plant. How do we integrate reaction kinetics, mass transfer limitations, thermodynamics constraint when designing an optimal industrial reactor? For that, you have to enroll into a chemical engineering course, and at the end of 4 years, you can answer that. So this is a very, very broad question, because you're saying this is a very important question, of course, but not easy to answer, because yes, we have to integrate all of these things so that we can design an reactor. Can the practicals in 1 minute, cooling agent used? CBSE syllabus is really useful in chemical engineering. Actually, see, the school curriculum will prepare you for all the disciplines. I mean, it's not just for chemical engineering. As I mentioned in the lecture, the foundation is, of course, what you're doing right now in school. So whether it's maths, physics, chemistry, biology, computational science. So these are basic subjects which help us then, branch out into different engineering. And depending on what the focus of the engineering is, we use, different extents of these subjects. So even some of the practicals that you are doing in CBSE syllabus or even state board syllabus, yes, they will be useful, because some of those is what will be useful in some measure. Yes, in the stirred tank, mixing and cooling is both done, because you have to make sure that there are no dead spots in the reactor, because dead spot, if the mixing is not being done, then reaction may not happen there, or reaction may happen too fast. Both of them are not good. So therefore, you have to keep mixing, and then depending on the type of reaction, whether it's exothermic or endothermic, heat is evolving or heat is being, absorbed, then we have to heat or cool. Yeah. What is the reason for? Yeah. So nickel. So somebody talked about poison, right? So what happens is, many of the times when these reactions are happening, some side reactions can happen, and then the products can deposit on the catalyst surface itself. And catalyst works by due to its surface. So reactant comes and then sits on the catalyst surface, and then the reaction happens. So now if some product forms, which is a byproduct, and it sits, so it will block. So generally, we actually quantify the activity of catalyst by saying how much active sites are there, how many, what's the number of active sites, and we say that, oh, catalyst is getting poisoned because its active sites are getting lost to the byproducts. So that's why in quite processes, either you have to include a regeneration of the catalyst, or you have to say that, okay, from once in a while, I should, supply some fresh catalyst and mix it with the catalyst which is present in the process, so that I maintain a minimum level of activity or active.
Sir, how can the regeneration of catalyst be done?
So it depends on what the poison or what the product is, but the safe, let's say if it's a hydrocarbon based, reaction, then most often the byproduct is actually, it's called coking of the catalyst, because basically it starts polymerizing, and it's basically you get carbon. So the best way to regenerate is to burn it. So you take the catalyst in another reactor where you just supply a lot of oxygen, and you burn the coke, and that is one easy way to regenerate the catalyst. Yeah.
That is the competitive inhibition only the factor for not using the same place, or are there any other reasons like deactivation of catalyst or such reasons, sir?
Yes, yeah. Deactivation is what the poisoning or deactivation is the reason that you want to keep on replacing some amount of catalyst. See, also these processes are being done on a continuous basis, right? So therefore, it's better that you keep on doing this process such that some amount of fresh catalyst is always mixed with in the reactor, so that the overall number of active sites remain constant. Otherwise, what will happen is, if you retain the catalyst within the reactor, initial first hour, the reactor will be very effective. then its effectiveness will go down. So one of the advantages of continuous process and why a lot of chemical industries operate on a continuous process basis is you basically get steady products. You keep on collecting the product, you keep on packaging it. So that it's not that you have to say, okay, first hour I will get one quality, second hour I'll get another quality. No, the target is to say that I will achieve the same product. If at all I have to make some other grade of product because of some other supplier, then what I'll do is 1 week I'll operate plant in one way, second week I'll operate in another way, and so on. So that you always get a steady state and a good quality product without much variation. So that's why then you do this thing where you take part of the catalyst and you feed in fresh catalyst so that you always have a good average activity. You can do this in batch mode also by saying that within the reactor, I will keep the catalyst fixed and I will not move the catalyst at all. It will not be in the form of a slurry, but it will be like a sand bed through which water can go. Similarly, this will be a catalyst bed through which reactants can go. Then what I have to do is I have to have two reactors so that one reactor will get used up and all the catalyst will get deactivated. So then I'll stop the reactor, I'll move to other reactor. When I move to other reactor, this reactor will have to go through a regeneration process. So then I have to use valves and pumps effectively to do this switching back and forth between two reactors. So that's also another way of operating. So some chemical processes will operate that way also.
Thank you, sir.
Yeah. Which kind of mostly used in chemical engineering? What that question is not clear by Alaguraj. Maybe you can just clarify what do you mean by that? Which kind of mostly used in chemical engineering? We'll move on to the next question. How do we integrate? That we have already answered that yes, we will need basically fair bit of knowledge of chemical engineering and details before we can actually design the reactor. So if you look at how engineering education is, right? So in the first year, you will still sort of do little bit more of foundations. So that in school, the approach related to these subjects is slightly different because the objective is for you to get to an answer. But as an engineer, when you say, I want to design a reactor, that answer is not there already. I have to figure out what may be a reasonable design. So therefore, as an engineer, we have to learn to come to these kind of problem solving where problem itself may not be very well defined. And there is definitely not one correct answer. So therefore, we again do some of the foundation courses with an emphasis of analysis and thinking and open-ended nature of, analysis. And then second year, third year onwards, you learn little bit more basics, thermodynamics related to chemical engineering, thermodynamics related to mechanical engineering. And then in the third and fourth year, you start saying, now I am ready to design because now I have acquired the capability of thinking about these subjects in an open-ended manner. Now I can start making decisions. For example, we just talked about, which fuel to use. So there are so many options. And so one therefore has to, and nobody can say that this is one correct answer. And so an important role of an engineer will also be to have one optimum answer with which the plant operates. But if there is a contingency and there is an issue, how do you have plan B and plan C also in place? So therefore, design involves all of these decision making. So that's why it requires, 4 years of sort of, education, foundations, scientific basis of engineering subjects, and then open-ended design. And so the economic constraint may not, so this we discussed already, saturated and superheated steam and what are their applications. Yeah. So, steam, as I said, like liquid water is also a very important utility. It's called utility basically because anytime you want to heat, anytime you want to, evaporate something, you want to heat something, you use steam. So you always have steam lines running around in a process plant. And so when you want a much higher degree of heat, it is better to use steam which is superheated, much more beyond the evaporation point. And so saturated steam sometimes is useful when you want, let's say, to utilize the heat which is involved in when steam goes to water, right? So the heat of evaporation is there, and then heat of liquefaction is there. So if you want to utilize that latent heat, then you can work with saturated steam. Okay, so the next question is somewhat again complex. The question is, entropy actually affect our real life? Does it affect industrial processes? So yes, the answer is yes to both of those. Because just the way we say that, look, does mass or weight affect our life? It certainly does, right? Whether I can pick up a bag and move depends on how heavy the bag is, and how I will lift it also depends on how heavy the bag is, and so on. So mass plays an important role when we are also looking at, let's say, pushing or pulling something. Again, mass and friction and weight, all of those play important role. So similar, just the way mass as a characteristic for objects is extremely important, we have a characteristic like internal energy, enthalpy, and entropy, right? So all of these are also extremely important characteristics. They define what the state of the material is. And so therefore, it's extremely important in terms of, how some things happen, how some things don't happen, which way will it be more efficient, which way will it be less efficient. So to do all these kind of thinking, so sometimes for our real life, we may want to just rationalize as to why something is not happening, and we may use entropy. But in a chemical plant scenario, we may want to have something more efficiently, and again, we may use entropy analysis to do that. So that's why entropy is quite useful concept, and that's why it has sort of stuck on. If you look at some of these concepts like mass, energy, force, yes, they are English, or any other language also. We have words for those, force, energy, but these quantities in terms of physical quantities which can be quantified, and it can be based on which we can solve problems, we can design things. So similarly, entropy is also one such quantity. Which is the most chemical used in chemical engineering? That's a very difficult question to answer because, of course, all chemicals, right? Chemicals, everything is a chemical, and chemical engineers are interested in transforming chemicals and separating chemicals and giving a chemical as a product. Sometimes trying to, do it through multiple ways and so on. So therefore, all chemicals are everything, basically. The best answer is everything is chemical. Of course, you can say, yeah, water is important. There are answers from yourselves. Sulfuric acid, yeah, but every chemical is equally important. Yeah. So another important question is what sticks to the dirt, and so you will have to look at. So what do you mean by dirt, right? So is it, let's say, a silicate particle, silica, or a silicate particle of clay? Or is it, oil from your food? So depending on that, you can have different parts of surfactant interacting. And that is the strength of how surfactant can interact with, different parts of whatever is soiling the surfaces that we want to clean. So this Haber process and all, we will again do through an example in a detailed lecture. So today I will not spend time on it. One other big important question that probably arises in a lot of people's mind is how much basic science of chemistry is does chemical engineering require? So actually, maybe first I will answer the reverse question. that, which are all the disciplines in which chemistry plays an important role. So, for example, in biotechnology, there are biotransformations where chemistry plays an important role. In metallurgy, material science, you have all these material processing, steel to be made. So all of these, again, involve large amount of chemistry. When we have semiconductor processing and electrical engineering, or let's say transformer, materials, insulation, oil being used, again, chemistry is involved because transformer has to function for 20 years without the oil actually aging. And so chemical transformations of the oil happen in the presence of electric field. So one has to understand what is the reason, how electric field is affecting oil aging. So again, chemistry is involved. So therefore, chemistry as a foundational subject is involved in multiple branches of engineering. Now, since chemical engineering is centrally also interested in making, these chemicals at large scale, chemistry is somewhat important because in each chemical process, we will have a reactor also in which reaction is happening. And so therefore, chemical reactions will be involved. So to that extent, we would need to know what kind of chemical transformations that are happening. How many basic lesson according to chemical engineering? I'm not able to follow that. If you can clarify that, then maybe I'll try attempting answering that, but I'll move on. Yeah, various chemicals like practical, like so some of these barium chloride, aluminum nitrate, some of these salt analysis and all are just basics. Some of that, see, many of these things, one thing that you have to remember, that not everything we learn is immediately useful in the next. Sometimes it is useful 4 or 5 years down the line. So therefore, many of these things are not necessarily always immediately relevant, but it gives you a way to think about it. So many of the time, the way the school and engineering curriculum is not to say that, look, you learn all this and when you join an industry, you will be able to use it immediately, whatever you have learned. No, the idea of this education is to make you a thinking individual. So some of these are examples by which we are trying to inform you how to think about these things. So when you join an industry, you think and you evolve your own solutions. So that's why it's important to look at a lot of these concepts that you are learning now as giving you the ability to analyze, to think, to be an individual thinker. And so sometimes it is directly useful, this information that you learn. Sometimes the way you process this information, that skill that you are learning becomes more useful. Yes, so delta G and all are also fairly important in the analysis. It will, so as I said, first courses in mechanical, civil, metallurgy, chemical will all involve a lot of thermodynamics discussion. Okay. The raw material which we use to generate electricity is obtained by the process of decomposition over millions of years, including some higher alkanes. Can we speed up the reaction of decomposition of dead organisms by using any catalyst for fastening? Yeah, so this is called using the biomass. So the way to sort of rephrase this question is that, look, biomass gets fossilized, and then we get to basically petroleum, and so that's why it's taken years, millions of years, to get to that stage. So now, is it possible to directly use the biomass which is available on the surface of the earth? And yes, there are many chemical engineers who are in fact trying to do this. They are trying various steps. So for example, some people have said that ethylene, rather than it coming from petroleum refining, I can try producing ethylene from biomass. So I can take agricultural waste, try to get ethylene out of it. So polyethylene that I get now is a bio-based polyethylene as opposed to petroleum-based polyethylene. So you can get variety of chemicals like that. The other approach is also to say that, look, there is starch already in the plant. Can I use starch to make a film which substitutes polyethylene? So therefore, we have lots of different, strategies which are being followed along these lines. That, given that that's a finite resource and it's a non-renewable resource as far as what is down there in terms of petroleum or natural gas, how can we arrive at strategies to have our energy needs being met through variety of other resources? Yeah, and some of you have also answered some of these questions. That's quite nice. Yeah, lab diamonds is also possible under heat and pressure. Okay, then what are the advantages to be a chemical engineer? So I don't know. Generally, advantage of being trained as an engineer is the fact that we get to do some of these tasks for a very practical scenario and get the product then which gets used by lakhs and crores of people. So that is the advantage really, that you are able to carry out a process on an industrial scale, a very large scale, and that product that you do gets used up either by another industry to make a useful product for a customer, or it is directly, like in case of shampoo, it's directly being used by a customer. So therefore, the role of engineer is to be able to bring products to the real world which are used, right? So that's why I said foundational subjects also, in addition to maths, physics, chemistry, biology, computational science, economics is also equally important. Okay. Yeah, long period. Time is major constraint. Okay, good. I see that some of you are also discussing the question related to, yeah. Ore is basically as recovered, and minerals can be in different stages of its treatment. I'm not sure whether this course certificate will be, let's say, immediately useful for an admission. See, because most programs, while giving admission criteria, will say, 12th marks or some entrance exams marks and so on. But our hope is that this will help you make a more informed decision. The idea also is that maybe you do, one or two such courses so that you get to know about 2, 3 different disciplines. And then, you can say that, look, oh, I already have, some knowledge in these, though I don't know exactly what it may be, but I have a good idea about it. So instead of just making a decision based on only discussion with some teachers, relatives, and friends, now I have seen what it is to be a chemical engineer, or what it is to be an electronics engineer, or what it is to be an architect. So what our NPTEL program is trying to do is to have some of these things available. And it might be good idea for you that if you are interested in 2 or 3, you do these, not because, let's say, this directly become useful. You show the certificate and you may get admission, because this is not a topic where we are, this is not a professional learning, right? So generally certification is useful. For example, when you do a 3-month course in, let's say even some computer language, then that certificate becomes useful because you can directly get a job on it. But 8 weeks course in chemical engineering is not that way a professional learning, which can be immediately useful for you to say, oh, I know this much. Basically, what you can say that I've been exposed to what are the different aspects. And now based on this, my knowledge, I will make a decision, or you can also in fact help others with, if they are struggling to decide, which career decisions to make. Given that you have done these 2-3 courses, you can all discuss. Somebody else may have done other 2-3 courses. So you can have more meaningful discussions between yourselves rather than just waiting for some others to fill you in, or just look at only 10-minute video. You have a more substantial learning now in a discipline. Okay. Can we contact you through mail? Yeah, sure. Email is a possibility, but also see, NPTEL has these sheets, right? It is circulating these sheets. So better it is to sort of pose questions in that, because then we can circulate it to other teachers. So as you know, in chemical engineering, we have 6-7 professors who all come with different expertise also. So therefore, for example, Professor Nitin, who gave a talk on control, his area is batteries. And some of them may be able to give you better insights in some aspects. So it's better to pose the questions in the sheet so that all of us can see it instead of mailing it to one individual. In surfactant, looks like maybe, okay. Length. Okay, good. There are already some answers. So I will just see if there are other questions which don't have any answers at all. Yeah, so see, for example, as far as alternative fuels, so one of the thought processes which has been going on as a society and as nations and as international community is related to, let's say, can hydrogen be a fuel? Because when hydrogen burns, you only get water. And so technically speaking, is it possible for us to do electrolysis of water to get hydrogen and then burn that hydrogen to get water? And then we have this sort of no emissions of carbon and things like that. So what's called hydrogen economy, is it possible to go there? So there are a lot of technical challenges from the point of view of material science, mechanical engineering, chemical engineering, electrical engineering. So many disciplines have to contribute before such a large change can happen, where we go from one carbon-based economy to a hydrogen-based economy. But so these are important things. Yeah, nuclear plants is another option, but given the the associated waste and its sort of threat, and many times also the perception of how deadly the threat can be, so it's not so easy to have proliferation of nuclear technology. More detailed courses from chemical engineering will not, I mean, so NPTEL has, of course, courses in all disciplines and in chemical engineering also. And so if you can watch some of those videos, they will give you an idea. But it may be a little early for you to, appreciate that, because the NPTEL courses are meant for, second year, third year, fourth year students. So, but maybe some of those, one-off videos may be very useful. If you are interested in one particular area, you could watch and see if, it helps you. Somebody asked already, can we use water as a fuel? So I already sort of described, saying what could be one way to, get hydrogen from water and then use it. Okay, so we have reached sort of 6 o'clock now. If there are further questions, please feel free to use the sheet which is circulated. I will go back and again I can consolidate some questions, and I can again release one video which is only talking about answers to some of your questions, so that you can watch that video as a capsule and get questions, and also it will prepare you for the next live session. So Mahalakshmi, can we close the session?
Yes. Every question.
Yeah. So we will also, this chat session, please share it with me so that I'll go through it. And in case some questions are unanswered, we will also release those answers as well. Because scrolling app, there's very good,
Definitely,
nice
sure.
discussion also among students. And in case, some of those questions are, require further detailing, I can do that. So please share the chat session with me. And any additional questions that students have, they will enter in the sheet and we will, of course, answer them later on. So thank you all. Thank you all for joining. This was quite a
Thank you,
lively
sir.
and nice session. And we will hope to continue this every week for the next few weeks. All the best to all of you. Bye.
Thank you, sir. Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Gomati ma'am. Gomati ma'am, can you hear me? You give session. So if you're facing any issue with your assessment, assignments, projects, please write to support of School Connect. You can take the mail ID from the
It's me,
stock
ma'am.
of your school. Okay.
Ma'am,
Thank you. Oh yes,
I
Harsh.
tried to log in into my dashboard using. I tried to log in using my email account, which I provided while registering. It showed something like, "Sorry, you cannot apply now. Applications closed on 16th September." So I can't access the videos or
Okay.
the
Okay.
assignment.
Yes. Take screenshot and send it to me. Mail ID can be done from the stock. Okay. We
Okay, ma'am. I
definitely look
just
at it.
they
Do
told
it
have an
as soon as possible.
support account. I messaged them, ma'am, about this.
Yeah, yeah.
Okay, ma'am. Thank you, ma'am.
Thank you.